Okay, today I'm going to talk to you about electric fields. An electric field is created around any electrically charged object, and if a second charged object is inside that field, a force can be exerted on both of them. So, how does something become electrically charged in the first place? So if you get two insulating materials and rub them together, they can become electrically charged. Now, how does that work? Let's just imagine here, I've got my pen right here, and I've got the cloth just here. So, when something becomes electrically charged, it's due to two insulating materials rubbing together and electrons being transferred from one to another. So in this case, let's just imagine electrons have been transferred from the cloth to the pen. It's only ever electrons that are transferred, never ever protons or neutrons, because electrons are in shells around the outside, so they are the things that are transferred. So in this particular instance, because the electrons have been transferred from the cloth to the pen is negatively charged because electrons have a negative charge. And this cloth, because it's lost electrons, this cloth remains positively charged. So that's how things become electrically charged in the first place. Now, in order to draw an electric field, we always remember that field lines go from positive to negative. So what I'm going to do first of all is just draw two of these things in isolation. So what we need to do to draw these electric field lines is, if it's positive, they are going to go out like this, from positive to negative. Now notice that always the arrows are coming out at a right angle to the base, to their starting point. So the electric field for this one looks like that. For my negative, because the field lines always go from positive to negative, it's going to look exactly the same, but this time all I'm going to do is I'm going to show all of the field lines. Oh, that wasn't very good, that one. All of the field lines, the arrows are pointing at the negative itself. So that's how we draw objects, electric fields, and the field lines in isolation. Now, the field, when the field lines are close together, that means the field is stronger. So we can see just here, these field lines are quite close together, meaning the electric field is quite strong here. So the further we get away, because these lines are much further away now, the weaker it gets. So the closer the lines are, the stronger the field. So all I'm going to do now is show you how to draw this thing called a uniform field, because sometimes we'll have these two different things interacting: a positively electrically charged object and a negatively. So let's imagine there I've got my positively charged object, and here I've got my negatively charged object. So I'm going to show you how to draw something called a uniform field, because if there's a positively charged and a negatively charged object near to each other, they're going to exert a force on each other. They're going to attract. So in order to draw a uniform field, what I do is, remember, the field lines always go from positive to negative. So when I'm drawing a uniform field, I need to remember three things. I should always draw at least three of these field lines. Second bit of advice, they should be parallel to each other. So we don't want one coming off at a funny angle. They should all be completely parallel to each other. And thirdly, they should all be the same distance apart. Now, I haven't done this one perfectly, because this gap looks slightly bigger than that one there, but they should all be evenly spread out. So when you're doing your uniform field to show the attraction between a positively charged object and a negatively charged object, three field lines, parallel, and all the same distance apart. And that basically is the underlying principles of electric fields. Thank you.